Greetings, everyone. I am Anshul Arora from Group 14 of Capstone, and the topic for our Capstone project is Collision Avoidance System. I have completed this project with the help of my teammates.
Greetings everyone, I am Vishesh Goel from Capstone Group 40.
Greetings everyone. I am Rahul Dev from Capstone Group 14.
Greetings everyone, I'm Iti Khare from ENC 5 of Group 14.
Greetings everyone. I am Daksh Marwaha of Capstone Group 40.
We have completed this project under the guidance of Poonam Verma ma'am, Gitanjali ma'am, whose deep insights have really helped us to complete the project and deliver the same today. Now, moving on with the next slide. This is the graph that shows the road accidents and the deaths that occur each year. According to the report published by WHO, approximately 13.5 lakh casualties every year happen in road accidents. These all can be avoided if the proper machine learning algorithms that we have created in our project if was deployed on the systems. Now, for the introduction, people involved in the crashes can suffer lifelong injuries. Current automobile safety techniques like ABS, that's automated braking system, and airbags have reached a plateau. The aim is not to survive the car accident, but to prevent it from happening. The world has reached a level of artificial intelligence where machines can not only predict what's happening around them, but also prevent the further situations that is likely to happen. So that's what we are doing in our project. That's the collision avoidance system. This is the project overview. We have been able to complete this project in the time period of 2 semesters. So we divided the work as shown above. Now moving to the next slide. We have created this project using machine learning and deep learning algorithms. Machine learning through the use of statistical methods and algorithms are trained to make classifications or predictions uncovering key insights within the data mining projects. The deep learning is essentially a neural network with 3 or more layers. For our project, we have used 25 layers to be efficiently predict if the accident can happen and to avoid it from happening. The main technology that we have used in our project is CNN, that's convolution neural network, that help us in analyzing image data, collect data points and their outcomes, which will help in training the model. LSTM, that stands for long short-term memory, captures the long-term dependency, while CNN extracts the time invariant features. As discussed above, along with CNN and LSTM, Python is our programming language that we have used to code these neural networks, and TensorFlow to provide accurate numerical computations and make neural network analysis easier. Now moving to the next slide. Program description. We have used Python as a primary programming language and Pygame to simulate the results. This programming does 3 things. Loads the sensor data collected and labels all the collision data as ones and rest of them as zeros. Creates a forward neural network and trains the labeled data up to 25 epochs, that's 25 layers for training. And later the collected data from a model is stored in a Python file named nnboot_model. Now the training steps that we have gone through for creating this model is object starts moving in different directions that will be represented in the later slide. The step 2 objects get collided with the obstacle and that is sent to the training module to learn from the collisions that have been made and prevent them. And third, collect the collision points and make a model learn. Moving to the next slide. Program working. Firstly, open up the simulator that we have created using the Pygame in the Python environment. The bot drives around randomly, sometimes bumping into the walls. All the sensor data is collected during these collisions. The program loads the neural network model and opens up the simulator. The bot is programmed to drive itself to the destination and feeding the sensor data to the neural network at every time step. If the neural network detects collision, the bot turns green and takes alternative action to the action it was planning to take. That's how our model is working. These are the snippets This is the snippet from the training of the model. You can see the red highlighting on the bot. That means it has occurred a collision during the training part itself. And these are the results when we have trained the model and it is predicting the right path. Now sharing some videos from our training model. As you can see, there are many collisions for our data points to be collected, and so that our model is trained to prevent collisions in the testing phase. Now, after the collection of the points, we have trained the model, and after training, the results are as shown in this video. The green light suggests that the bot was about to hit the object, and using the model itself, it has prevented it from happening and taken a better alternative path. For conclusion, real-time crash prediction can only be possible with the help of deep learning methodologies such as CNN and LSTM. Even after good accuracy for avoiding obstacles, this model has scope for further improvements. With such progress, this can be deployed in the real world to solve the major problem of casualties happening in the road accidents. Future scope, as discussed before, it can be really helpful if deployed on the real world vehicles so that drivers are intimated beforehand, before the collision takes place. It can be used for the implementation of advanced traffic management system, which has the potential to reduce accidents. Our dataset lacks driver characteristics, their presence of mind, and their reactions for handling the situation, which could either be helpful or more dangerous. So that's all we have created for a Capstone project, and hope you guys like the project. And now we are open for questions. Thank you.